well known as a promising oxidation catalyst and utilized in numerous reactions, such as low-temperature dehydrogenation of ammonia, hydrochloric acid oxidation, and alcohol combustion. Ruthenium dioxide has been extensively studied in the surface science community, and it's well documented that ruthenium displays a pressure gap where the metal surface is inactive for CO oxidation, but then becomes one of the most active catalysts for CO oxidation if the oxygen ambience increased. So Herbert Over is well known for his contributions towards understanding ruthenium chemistry and is partially responsible for the discovery that this increase in activation is due to the formation of an oxide layer at the surface. And this oxide layer is what allows for CO adsorption and then leads to CO oxidation. So this figure here is from Herbert's science paper, and it overviews the comprehensive oxidation chemistry for ruthenium, where we have slow oxygen dissociation on the surface, which leads to chem-adsorbed oxygen, forming a 1-by-1 monolayer structure. It's also known that oxygen can be stored in the lattice of ruthenium. And then additionally, towards this rutile phase, we have the formation of metastable ruthenium dioxide nuclei on the surface, and once stabilized, leads to this fast oxygen dissociation, which then forms this autocatalytically forms this rutile structure. So we know the proposed mechanism is rather well understood, but it does not fully describe how this rutile phase forms. And so what we'd like to do is characterize these potential metastable precursors with APXPS. So there's a DFT paper by RuO2 et al. That they discuss potential precursors using density functional theory. Here we see that from their results, initially you get a 1 monolayer on the surface, and once this forms, you get some oxygen to penetrate into the lattice, forming this 2 monolayer coverage. And this is what they call an oxygen-ruthenium-oxygen trilayer. Further oxidation actually leads to this trilayer being detached from the substrate and what's called a floating trilayer. And if you have enough of these trilayers stack on top of each other, you then form this rutile phase. So unfortunately, this trilayer structure is expected to be metastable, which means that in order to fully characterize it, we need a very fast acquisition for characterization as well as high energy resolution. There has been thermal desorption spectra to try to characterize these trilayers, but obtaining XPS has been rather difficult.